Hello everyone, we are Team EarthLens from the Indian Institute of Technology, Kharagpur. Our team ID is 85896. Our problem statement ID for the Smart India Hackathon 2025 is SIH 25176 in the software category. The theme of the problem statement is space technology and it is provided to us by the Indian Space Research Organization. The problem statement title is to develop artificial intelligence machine learning based models to predict time varying patterns of the error buildup between uploaded and modeled values of both the satellite log and ephemeris parameters of navigation satellites. So moving on to the solution part. We have developed an AI and machine learning based system to predict satellite log and ephemeris parameter errors for navigation satellites. Our goal is to accurately predict these time varying errors for the next day using only the previous 7 days of data and make sure that the predicted errors follow a normal distribution as much as possible. Now, since these errors are influenced by multiple parameters such as orbital geometry, solar radiation, and onboard clock behavior, simple AI models and deep learning techniques may not be able to predict the error for day 8 accurately. Hence, we have done a bit of feature engineering before employing deep learning techniques. Now, our model combines several AI techniques, each with a specific purpose. Firstly, we have used generative adversarial network, which learns to generate realistic synthetic GNSS error sequences. This helps us overcome limited training data by creating additional and realistic examples. It produces artificial error sequences that mimic real behavior, and the discriminator ensures these look physically plausible. Next, we use the LSTM model, or the long short-term memory network. This is a recurrent neural network that captures temporal dependencies. This also helps us in identifying long-term dependencies in the data. This is crucial for GNSS errors, which often have slow and periodic drifts along with short-term fluctuations. Then, we also use the transformer. For longer-term dependencies like periodic patterns that span multiple days, we integrate a transformer encoder. Transformers handle long-range relationships much better than LSTMs because they use attention mechanisms instead of memory cells. This helps the model detect repeating daily cycles or slow drift in ephemeris errors. After the LSTM and the transformer makes its predictions, we have used a small Gaussian process model to refine the short-term forecast, basically acting like a local bias corrector, adjusting for systematic deviations and giving us uncertainty estimates, which help us to quantify confidence in each prediction. Now, to make sure predictions stay physically realistic, we add small penalty terms in the loss function. These terms encourage smoothness, prevent sudden and unrealistic jumps, and even account for known periodic behaviors in GNSS errors. Also, the reason for not using the ARIMA model was because the GNSS errors are highly nonlinear and non-stationary and are influenced by multiple factors as mentioned before. And since ARIMA models work best on stationary data, even differencing would probably not lead us to a perfectly stationary data. Hence, the ARIMA model was not used in this pipeline.
Content of our proposed solution. We have created a website called SCOPE, which stands for Satellite Clock and Orbital Parameter Error Predictor. As we can see, this is the homepage of our website. We have a planet surrounded by a few of its satellites. Now, let me consider the Geosynchronous Equatorial Orbit Satellite, or the GEO satellite. This is the GEO satellite that I'm pointing at currently. Let me click on it. Once I click on it, as we can see, on the right hand side, in the error prediction tab, we have displayed the errors in satellite log and the ephemeris parameters at different time intervals at 15 minutes, 30 minutes, 1 hour, and so on. Similarly, it can be done for other satellites by clicking on them respectively. We also have a search bar option. Let's say we have multiple satellites. Now I'll search for GEO. And as soon as I do it, on the main screen, all the other satellites disappear and I'm only left with the satellite that I searched for. This is a really useful feature in case of multiple satellites. Now, on the bottom left side, we also have a view 7 days error data option. Once we click on it, using the data that was provided to us of the previous 7 days, we have a graph which shows us the errors of the ephemeris parameters, and similarly a graph which shows us the errors in the satellite log data for the previous 7 days. This is for the GEO satellite. Similarly, once I click on the MEO satellite or the medium Earth orbit satellite, a similar graph is obtained with error values pertaining to the MEO satellite as given to us. As we hover over the graph, it shows us instantaneous error values at different time steps for both the XYZ coordinates as well as the satellite clock coordinates. So this is our home page, as I said before, and also we have a last data update display, which also shows us the last time when the data was fed into the model.
For the front end and back end of the website. This is our Google Drive. It consists of the main file which has the error predictions for day 8 and the YouTube video along with our presentation for the problem statement.